Surface tension is a property of liquids because of which the surface of the liquid behaves as if like it is stretched. There is some kind of a tension who's pulling it, right? Before defining what is that surface tension is, first we would like to explain why does the surface tension happens? How can we explain surface tension? We can explain it basing on a theory called molecular theory. As we have done in the previous lessons, I said every molecule can attract the neighboring molecules up to some extent. It can influence the other molecules. That's called the range of the molecule. Take the molecule as a center and the range as a radius. Draw a three-dimensional sphere. That's called sphere of influence. Taking these basic concepts into consideration, we would like to explain the reason behind the surface tension. Why there is a surface tension. So let's imagine a liquid in a vessel. So this is a vessel. I'm taking a big vessel. Imagine something like water up to certain level. The surface need not be of this shape, like flat. We'll explain that little later once when you go into the lesson, right? So this is the liquid. In this liquid, we would like to consider three different molecules. One molecule deep inside the liquid, one molecule close to the surface of the liquid, one more molecule on the surface of the liquid itself. Let me name that molecules as A, B, and C. Each of these molecules have their molecular range. They can attract the neighboring molecules up to some extent. So this is, let's assume this is its molecular range. Taking this molecule as center, molecular range as radius, I can draw a sphere which is called as sphere of influence, as I have explained earlier. So this sphere of influence is full of water molecules, right? So this molecule is attracted by molecules of the left towards the left, attracted by the molecules of the right towards the right, equal number of molecules because that's completely filled, that sphere of influence. So the pull towards the left is balanced by pull towards the right. So there is no force, resultant force in that direction. Similarly, there are equal number of molecules upward who are pulling it up, equal number of molecules downward who are pulling it down. So that force is also balanced. Similarly, on the given molecule A, in every direction, there is symmetric number of molecules applying equal amount of forces who are being balanced. That means on the molecule A, there is no resultant force. So what we can say on molecule A, that is on molecules inside the liquid, completely inside, F resultant is equal to 0. Why F resultant is 0? Upward force is balanced by downward force, left side force is balanced by right side force, and so on. That means that molecule doesn't experience any resultant force. So there is nothing like a tension at all. Now let us consider the molecule B that is close to the surface of the liquid. This one, this molecule. This molecule also has some range. It can attract the neighboring molecules up to that extent. Take that molecule as center and the molecular range as radius and draw a sphere. My sphere is not perfect. Please excuse me for that. Yeah. Now on this molecule, the left side molecules applies a force of attraction. The right side molecules also applies a force of attraction. So that is balanced. But if you look at this sphere of influence little carefully, look at the sphere of influence. Up to this part, this sphere of influence is full. But look at this part of the sphere of influence, that is empty. There is no water molecules in that part because that is above the surface of the water. So the sphere of influence A is completely filled with molecules, whereas sphere of influence B is only partially filled. Up to this extent, this is full, but look at the upper extent, this part that is empty. As it is empty, there is no molecules to pull the molecule in that direction. Then what happens? This molecule is pulled by left and right equally but there is more molecules to pull it downward than the molecules to pull it in the upward direction. Isn't it? See, this is the upper part of the sphere of influence is empty because that's above the surface of the liquid. Means what? For molecule B, that means for molecules near the surface, not on the surface, near the surface of the liquid, what happens is, see, this left side force, this directional force is also not that much balanced. This directional force is also not balanced. Everywhere there is more forces acting in the lower half of the sphere than the upper half of the sphere. As a result, all that resultant force together acting in a downward direction is more than the force acting in a upward direction. So for molecules near the surface, if resultant is not zero, that is there. What is there? F downward is more minus F upward, which is less. I have written minus because they are acting in the opposite direction. So there is some sort of a resultant force acting on the molecules near the surface who is acting in the upward direction. As the upward directional force is dominating, the resultant force is also will be in the upward direction. That's about the second molecule. Now let us consider a molecule on the surface of the liquid itself that has some range in every direction. You draw a sphere of influence like this. What do you see? The entire lower sphere of influence, sorry, the entire lower sphere of influence is full of liquid molecules, water molecules, whereas the upper sphere of influence, this part, is empty. Why it is empty? Because that sphere of influence came above the surface of the liquid, where there is no liquid molecules are there. Liquid molecules are there up to only the surface only, and that half of the sphere of influence has gone above that sphere. So you talk about the molecules on the surface of the liquid. There is molecules pulling it in downward direction. Left and right are balanced because there is equal molecules. But there is more downward forces, but in upward direction is not there. Why it is not there? There is no molecules on the upper part of the sphere of influence. Therefore, there is no one to pull the molecule C in upward direction. So what we can say for molecules on the surface, yes, resultant is F downward minus F upward is 0 because the sphere of influence in the upper part is empty. So there is no molecules to pull it in upward direction. So it's going to be only F downward. And, and that force acting in the downward direction is maximum. Is maximum. So what we can conclude is the molecules on the surface of the liquid, what is the conclusion is? Molecules on the surface experience maximum downward force. So what happens when the molecules on the surface experience a maximum downward force? Let me visualize and draw a fresh diagram for you just to explain that once again, right? I will just roll over the space for a little so that I can draw a fresh diagram. Yeah. So I will try to visualize what is being we have found. So I'm drawing the liquid surface once again in a vessel. Is the surface that we have drawn. There is no big deal about the molecules inside or molecules near the surface, but molecules on the surface, this is the surface, are very important for us because they are experiencing a maximum downward force. So everywhere there is a maximum downward force. So because of this downward force, this behaves like a stretched elastic membrane, just like that. So the surface of the liquid behaves like a stretched elastic membrane because of this property called surface tension. Once again, there is one more point that I want to tell you here. At these points, contact points, what you call this as, This is the point where vessel is in contact with the liquid. These are the 2 points on the surface. Here there is a force of attraction, molecular force of attraction called adhesive force, as I told you in the previous lesson, between whom? Vessel molecules and liquid molecules. There's an extra adhesive force there, only at the edges of that vessel, but not anywhere else. And all other parts are only coercive forces and surface tension forces. Because of this extra forces of attraction, the molecules at the edges that are in contact with the vessel are more attached with the vessel than the remaining part of this molecules. So what happens because of that? These molecules that are there at the edges will be there with the vessel itself, whereas other molecules, because of all this,
Understand what you meant by that question.
because of that, all these molecules comes little downward. There is a downward force. So because of the downward force, this surface just changes its shape this way. So the liquid surface behaves like a stretched elastic membrane, and the shape of the surface is never flat for a liquid. If you observe a little carefully, we can find that. This is all because of the property called surface tension. So I'm defining surface tension in the further video, but here I would like to say, just to conclude, the molecules on the surface experience a maximum downward force because the upper sphere of influence is empty, but the molecules that are in connection with the vessel have another force, adhesive force of attraction. Therefore, they are more bound to stay with the vessel, but other molecules are pulled down. So the shape of the surface changes into a kind of a concave in this case. It can be convex also in some other cases. We'll discuss it as we go further. But the surface behaves like a stretched elastic membrane. Because of this property, the surface tension happens, and how much is its value, how do we define, we will deal it in the next video. Thank you for watching.